Today we'll be looking at the basics of NumPy arrays. Here we'll be discussing about the basic array manipulations, where we'll be covering number 1, attributes of array, number 2, indexing of arrays, number 3, slicing of arrays, number 4, reshaping of arrays, and number 5, joining and splitting of arrays. Number 1, NumPy array attributes. First we'll import NumPy. Then we'll use NumPy's random number generator, which will seed a set value in order to ensure that same random arrays are generated each time the code is run. Then we'll define 3 random arrays, a 1-dimensional array, a 2-dimensional array, and a 3-dimensional array. Now we'll be introducing with the following attributes. Ndim will give the number of dimensions, shape will give the size of each dimension, and size will give the total size of the array. Now we'll try to print the above arrays using these attributes in Google Colab and see what the output is. When we run this, we can see that we get the outputs as discussed above. Another useful attribute is the dtype, which gives the data type of the array. Now we'll try to print the dtype attribute. When we run this, we get the data type of the array. Other attributes include item size, which lists the size in bytes of each array element, and n bytes, which lists the total size in bytes of the array. We'll try to print using these attributes. When we run this, we get the sizes in bytes as discussed above. Number 2 is array indexing, accessing single element. We know in a 1-dimensional array, the ith value counting from 0 can be accessed by specifying the desired index in square brackets. First, we'll display the array like this. Then we'll access the desired elements from the start of the array by specifying using positive indices. We'll do it like this. When we run this, we get the desired elements. Now we'll access the element but from the end of the array using the negative indices like this. When we run this, we get the desired elements. In a multi-dimensional array, items can be accessed by using the comma-separated tuples of indices. First, we'll display the array like this. So now, we'll access the element like this. When we run this, we get the desired elements. Values can also be modified using the above index notation like this. When we run this, we get the intended changes in the array. We need to remember that NumPy arrays have a fixed type unlike Python lists. For example, if you attempt to insert a floating point value to an integer array, the value will be truncated like this. When we run this, we can see that the element has a truncated value in the array. Number 3 is array slicing, accessing sub-arrays. We can also use the square brackets to access sub-arrays with the slice notation marked by the colon. The NumPy slicing syntax is this. However, if any of the values is not specified, then the default value is this. Now, we'll try to look at how to access sub-arrays in the 1 dimension. First, we'll display the array like this. Now, we'll try to print the array using the above syntax. This prints the first 5 elements. This prints the elements after index 5. This prints the elements between the index 4 and the index 7. Now, this prints every other element starting at index 0. And this prints every other element starting at index 1. However, when the step value is negative, the default for start and stop are swapped and results in a reversed array. We'll try some few examples. This prints all elements but reversed. And this prints reversed every other from index 5. Now we'll look at how to access sub-arrays in a multi-dimensional array. Multi-dimensional slices work in the same way with multiple slices separated by commas. First, we'll display the array like this. This prints 2 rows and 3 columns. And this prints all the rows and every other column. Also, the sub-array dimensions can even be reversed together like this. When we run this, we get the array where both rows and columns are reversed. It is very important to know that the array slices return views rather than copies of the array data, and this is what NumPy array slicing differs from Python list slicing. Now, we'll consider the above 2-dimensional array. First, we'll print the array like this. Then, we'll extract a 2x2 sub-array from the above array like this. Now, if you modify the above sub-array, we'll see that the original array is also changed. Let's see, we'll modify the above sub-array like this and print it. Then we'll print the whole two-dimensional array like this. We can see that the original array is also changed. Although there is a feature of array views, it is useful to copy the data within an array or a sub-array, and this is done by using copy method like this. Now, if you modify this sub-array, the original array is not changed. We'll modify the above sub-array like this and print it. Then we'll print the whole two-dimensional array like this. We can see that the original array is not changed. Number 4 is reshaping of arrays. The operation of reshaping of arrays can be done by using the reshape method. So we'll put the numbers 1 through 9 in the 3x3 grid like this and print it. We can do the reshaping only if the size of the initial array matches the size of the reshaped array. Another common reshaping pattern is the conversion of a one-dimensional array into a two-dimensional row or a column matrix. We can do the reshaping using the reshape method as well as the new axis keyword. First, we'll initialize the array. Now, we'll print the row vector via reshape method like this. We can also print the row vector via new axis keyword like this. Similarly, we'll print the column vector via reshape method like this. We can also print the column vector via new axis keyword like this. And number 5 is array concatenation and splitting. Till now, we have worked only on a single arrays. It's possible to combine multiple arrays into one and conversely split a single array into a multiple arrays. First, we'll do the concatenation of arrays. It is done using the routines such as np.concatenate, np.vstack, and np.hstack. So we'll initialize the two arrays x and y and do the concatenation of it like this. Also, we can do concatenation of more than two arrays at once. So we'll initialize again an array z and print the concatenated array like this. We can do the concatenation for two-dimensional arrays in the same way. We'll initialize the array and do the concatenation of it to itself along the first axis like this. We can also do the concatenation along the second axis like this. For working with arrays of mixed dimensions, we can use the np.vstack vertical stack and np.hstack horizontal stack functions. We'll initialize the two arrays x and the grid and do the vertical stack of it like this. Similarly, we'll initialize another array y and do the horizontal stack of the arrays grid and y like this. Now, we'll do the splitting of array into a multiple arrays. We can do it using functions like np.split, np.hsplit, and np.vsplit. We'll initialize an array x, then we'll split the array x into the arrays x1, x2, and x3 and print it like this. Now, we'll showcase how the functions np.hsplit and np.vsplit does the splitting. So, we'll initialize an array with numbers 0 through 15 in a 4x4 array. So, we'll do the vertical split of the above array and print it like this. Similarly, we'll do the horizontal split of the above array and print it like this. These are the basics of NumPy arrays. Thank you for watching this tutorial.